Okay, let's start our class today. So today we will learn something related to macro, constants, function overloading, and default arguments. For macros, actually, we have already learned macros in previous classes that is related to headers. So for macros, we learned that we can define a macro and then we can check in the header file whether it is defined or not by this if-def. Then we can prevent multiple inclusion of the same header file. So macros can be used to define values, and it is an improvement over these magic numbers. So in our program, if we use these magic numbers, it is difficult to debug and it is error prone and difficult to maintain. So if we use macros, it is better now. It has had some meaning and easier to maintain. So we can define some values for different macros like this. And we can define a macro over other macros like this. But actually this is error prone. We will learn that later. So we can define some functions like this. There are also some useful macros. So and this one is for the function name. That means in our source file, we can use this keyword or macro. We can use this macro to report the function name. And this one is for file name. And this one is for the line number. So for example, we can print the line number for some line. That is exactly where we print the line. The line number will be reported. And this time and date are used similarly. We can end after a macro value like this. This is helpful to avoid name conflicts. For example, we can define a pi here, and then we can use a pi in this part of the program. And then when we are sure that this value is not used anymore, we can end this value. So in the following part, we can use pi to denote other variables without name conflicts, okay? Another very important macro is assert. So assert is for debugging. So actually all macros are defined by preprocessor or processed by the preprocessor. That is before compiler or before the compiling process. So this is how we use assert. For example, we have some program here, and there are some lines of code to compute the value. Now we know when we compute the value, we know it should be greater than 0. However, if there are some bugs here, then the value may not be greater than 0, or it may be equal to 0 or less than 0. In this case, we know that there must be some bugs in this part of the code. So this assert will fail. If this assert fails, program will be terminated. So in this case, we can debug our program. So this is really very helpful to debug our program. If we know during our computation process, we know some value should be have some properties, greater than 0 or equal to 0. One value is equal to another value, things like that. If we know that conditions, please use assert. This is very helpful to avoid bugs. Okay. So to use this assert macro, we need this header file. And for most programs, our development stage consists of 2 stages. One stage is the debugging stage, because it is really difficult to write a program all correct, right? So the first stage is program and debug. Then when we know that our program runs well, then it can be released to third party to use. In that case, we come to the second stage, that is release stage. So we will release our program. When we release our program, we should avoid this assert because it takes time. Every assertion will be checked, right? So we can avoid this or disable this macro by another macro named ndebug. So way number one to define this is to define this macro in the source file. Another one is to define this debug by the compiler option. Either way works fine. So in this way, if we define this macro, then this macro will not be used. It will be removed in the release version. So in this way, the runtime is significantly improved. Our program runs faster. So this assert is very useful and very convenient to use. So I suggest our students to use this assert when we write our programs, okay? Then although we have learned something related to macros, our design principle is that try to avoid macros as much as possible. Why should we try to avoid it? That is because macros are processed by the preprocessor. So there's no type checking because the preprocessor is really very simple and straightforward. Typically do something related to text substitution, like that. For example, it will replace some macros by values. So there's no type checking. And also there's no symbol table. Actually, symbol table is a notation in compiler. The variables will be put in the symbol table for debugging. When we debug the program, the symbol table will be used. However, macros are not recorded in the symbol table, so we cannot find the symbols. We cannot debug those symbols defined by macros. So macros are not safe. Okay, so that's why we should try to avoid macros as much as possible. And there are indeed alternative ways. One is const, another one is enum and inline. We will learn this in the following classes. Then we can use this instead of macro. They can replace where macro is used. So because these are compiled during the compilation process, so that means we prefer compiler. We prefer compiler to preprocessor. Macros are processed by compiler, by preprocessor. So we prefer compiler to preprocessor for better safety and type checking and debugging, more convenient usage. Okay. Now we learn something related to const. Const is a substitution of macro, actually. So const is a new keyword in CPP language. Actually, in C programming language, there's no const. So const is used to define read-only variables. Okay, read-only. For example, we can define a const like this. Then we can use this const to define an array. Right? Because this const will keep unchanged. And also this const variable will be initialized at the beginning. So the compiler actually can know this value, right? Compiler knows this value. That's why the compiler can define an array using this value. Otherwise, we cannot do that, okay? And also, we cannot modify it. It is read-only. So const can be used for built-in types, such as characters, integers, floats, and pointers, etc. And function arguments and return types can be used with const, also class objects. So const defaults to internal linkage. So it is visible within, only within source file where it is defined, and invisible in other translation units. Therefore, definition of const variables can be put in header files without causing linking errors. Okay, now we have an example here. You can see here we have a const example. So this is one source file. In this source file, we have a function, and in this header file, we have a const variable, right? And we also have the function declaration. And in this source file, we have the main function. So we can, because we included header file, so we can call this function, right? Call this function area to calculate area based on the radius. So we output two versions. One is using this function area. Another one is just compute it in main. Let's check the results. So already compiled. Can run it. So we have exactly the same results. Here, fixed and set precision are functions of cout. So set precision, for example, is used to get the number of decimal points. Set the number of decimal points. Okay. So this is the result. Nothing interesting actually, but we can do this. Okay, and here, because we define this const in the header file, we just mentioned that we need to, or we are suggested to define const variables in the header file. So this is correct way. But if we do not do it, it's still fine. In this, if we just do not define it in the header file, but we define it in the main file here, and also in this area file here. So we have two definitions of the pi, right? Two definitions of the variable. One is in main, another one in this main we have 3.14, and in this area we have 3.14159, right? So we have different definition of the pi. Now we can check whether it can compile or not. Compiled correctly, right? So results are different because we have different definitions of the pi value, right? So this indicates internal linkage. So internal linkage means so this definition of a const variable only visible within main.cpp. It is not visible within area.cpp. That is why we can define another pi here. Otherwise, there will be name conflicts, right? Multiple definitions. So there will be such errors. So that's because const variables are internal linkage, so there's no conflicts, no compiling errors, works fine. Okay, so this is internal linkage. So be careful about this because we have actually many different definitions or many different grammars related to this internal linkage. So const is also is internal linkage. So we mentioned that actually static. We will learn static later. Static and inline. These are const static, inline, internal link. Okay. Inline is internal linkage, I think, right? So someone asked internal linkage again. So internal linkage in Chinese 内部链接。So it means when we compile this, it's only link within area.o. Right? This is internal linkage. It is not linked to main.o. Okay, so because in this area.cpp we defined constant variable pi, right? And in main.cpp we also defined constant variable pi. So they are all linked within their self. So they are not cross-linked. That is why there's no multiple compilation, multiple definition error. If it is external linkage, 就外部链接的话，如果是外部链接的话，那这个里面定义的派，在这边就可见。那这边再定一个派，就会有名字的冲突、命名冲突，因为它们是内部链接啊，都是在各自的这个编译单元里边编译，所以呢，它链接就是只是在自己的编译单元里面链接的话，没有问题，没有问题。So the variables are linked within themselves, within this translation unit, and separately within this translation unit. They are not cross-link. That is why this pi variable can be defined separately within these two source files. Okay, and this is internal linkage. Okay. So inline is also internal linkage. Okay, so using these const variables, when we define a const variable, we also need to initialize it. So this is grammar. Because const is read-only, right? We learned that const is read-only. So we have to initialize it when we define it. Okay. So it's similar to, so we can also define a const object like this. It also calls constructor. So it's also defined and at the same time initialized. After definition, it is read-only, cannot be changed, unless by constcast. We will learn constcast later, but this is not a safe way of programming. Actually, for a const object, we should not use constcast in most cases. Okay, to make an explicit declaration without initialization, if we only want to declare, then we use extern. This is another keyword. We use extern to declare something. So actually, we also learned extern before, right? So extern is used to declare. Right? We can declare functions. We can declare variables, but for functions, this keyword can be omitted. 就是函数声明的时候，我们可以把这个关键字把它省略掉。但是变量声明的话，这个是必须的。So For better runtime and storage efficiency, use const whenever a variable does not change throughout its lifetime. So if we know for sure that this variable will not change, so then we should use const, okay? So besides macro and const, is there another way of defining an array like this? So this is the question. So we can use enum. So enum is another structure. Actually, it is used for enumeration actually. So we will not explain too much related to enum. For those who have not learned it, can read our book on enum. Const variables should be initialized at the very beginning. Otherwise, there will be errors. Okay, when we define const variable, they should be initialized at the same time.就是我们在定义的时候，定义 const 的时候，一定是定义变量的时候，一定是同时要进行初始化。那如果是 extern 的话，那是声明，就是说定义已经定义过了，声明只是为了使用它啊，我去声明一下。所以是在某种情况下，如果我们比如在这个当前的这个比如说啊，打个比方，就 extern 的话，这个是就我们前面课程讲过了，就是说任何情况下，我们对一个变量的一个使用都可以用 extern 来声明啊。当然这个情况其实可能会比较少见啊，可能会比较少见啊。那大家记住，就是说 const variable 啊，定义的时候呢，就可以在这个extern const 我觉得在任何地方都可以吧，extern const 就 extern 的声明就是你要用这个变量的时候，你就可以用 extern 来声明。我觉得前面这个可能有一点点误导，就是说大家在因为 extern 声明的话，我们变量声明这一块我们定义讲过很多次了，就是前面已经讲过了。大家记得进行这个声明的时候，只要做这个用 extern 来声明就可以。对，这个是用来，比如说做这个外部链接的话，如果需要的话，这个可以可以用 extern 来进一步声明。这个相关的语法，大家如果需要的话，可以看一下。Okay, so extern can also okay. 对于 enum 的 so for enum we do not have time to explain too much about this. Actually, for enum we just define some integers. Actually, we use these integers to represent the values. So this is the key idea. We use this enum to define a enumeration type. So this enumeration type may have different values of integers. So we can use these integers to define an array. So this is the key idea. Okay. Actually, we also have a very simple demo here. So here's the enum. So actually, enum we can give enum a type like this. So next we can use it similar to a basic data type or a class. Right? We can use it in this way. So we define this size type variable like this and give it a value. so it's fine, right? So this is enumeration type. So in this way, we can define some integers. Now we can use the integers to define arrays like this. So this here we check the size of the class bench and also check the size of integers of 1000 integers. Now we get the results. We can see here. So the size of the class of is 4000, and also size of integer array is also 4000, right? So this means this enum type does not take storage, right? Actually, it takes storage, but the storage of enum type is not within the class. That's why the object or the size of the class is still 4000. That is equal to this integer array, right? Because one integer is 4 bytes, and then this array takes 1000 elements, takes 4000 bytes, right? So this part does not take the enumeration type within the class. Actually, is stored in another place, another part of storage. It's not within the class. That's why it takes only 4000. Okay. If we open this, we use this enumeration type to define another type, and we give it a value, and then we can I think we can print this value as sorry, should be a public. Okay. So so we can define an object, and we can get this value of this enumeration type, right? Okay. Then we can see the size of class is increased by 4 bytes. So this enumeration type variable takes 4 bytes. And then this is the value of this enumeration type, right? So now it's more clear for enumeration type. The variable of enumeration type is integer, actually, is an integer. Okay. So you just learned that much about enumeration. For those who are interested in this, please read the book and learn it by yourself, okay? Because of the limited time, we have to go faster, okay? For const arguments, we can use const to in the arguments in functions. So we can pass by value, actually. There are 2 ways of function arguments. One is pass by value. So pass by value is mostly used. For example, here, if the parameter is like this, or if the parameter is like if the parameter is like this, f1 plus a, right? This is pass by value, and this is pass by value, okay? Then if we call this function, when we call this function, a copy of the arguments is made and passed into the function. So what does it mean by a copy? For example, if we define a variable here, and then we call the function here, f1, a, then a copy of this A will be made to this I. So this value will be made here, make a copy here. So within this function, we access I, not A, not A. Okay, so this is the problem, right? This is the problem. Because const, if we use const here, and that means we do not want to modify this parameter, right? However, because it is already a copy of the original parameter, then modifying this variable is meaningless, right? It does not affect original parameter. So modifying this variable is meaningless. So, and in this reason, if we use const for passing by value arguments, that's meaningless. Okay. Another way of passing values is pass by address. So we can use pointers and references. We will learn references later. Learn this later. So const ensures, if we use const, it ensures safety because we cannot modify it. It is read-only variable. We learned that. Okay, then if we call this function in this way, here, for example, here, if we define this function f2 in this way, and then we want to yes, and then if we want to modify this value, this causes compiling error because it is const. We cannot modify the object pointed to by this pointer. Okay, so in this way, we can help to prevent from modifying the original value. For example, if we call this function this way, f2a, right? Then in this way, this value is not changed. We cannot change it because this is const. We can be safe, right? We can feel safe because this value can never be changed. Okay, so const is useful in passing by value arguments to prevent the function from modifying the parameters. Okay. For reference is similar. We'll learn reference later. So this is safety control by passing by address. If we are sure that the arguments are not changed, or if we are sure that we do not want to modify the past arguments, then we should use const. Okay. And this is function arguments using const. Then we will learn how to use const in class. The const member variables keep constant for the lifetime of the object. So if we define some member variables as const, so they will not be changed. And we can also define const member functions. These const member functions cannot modify any member variables and cannot call any non-const member functions. They can only access const member functions, can only access const member variables. Right? So they corresponds to this one, corresponds to const member variables. Then constructor initializer list. If we want to initialize const members, here is the place. So constructor or member initializer list. Actually, there are two names. One name is constructor initializer list. Another name is member initializer list. They're all fine. Okay. So this is a way to initialize const member variables. Okay. We cannot do that in the constructor body, so we cannot do that here. Okay. So in both general functions and member functions, the following code works. So this one and this one. The question is, does this work if it is in the class? So actually it does not work, because the compiler cannot know it, right? Because this is done by the user, and this value is not known before we define an object. So we cannot do that. Compiler do not know the size of the array, so we cannot define the array. Okay, so we can use enum, and we can use const static member variable. So we will learn this next class. Okay, so we can define this as const static, right? Static in this way. Okay. Then const objects, member variables cannot be changed. For this const object, for example, this one, so we cannot modify the member variables, but we can access the variable. So compiler will check whether this value is used as L value. L value means is to the left hand. L is left, to the left hand of the equal sign, right? Assignment operator. So if it is L value, then compiler error. It is R value to the right hand is fine. Okay. And then only const member functions can be called. So a const object can only call const member functions. Okay. Then const keyword can only be used for member functions, not for general functions. So we cannot define const general functions. Okay. Here's an example. We can see here we have show, and this is const, and we have another show, the non-const version. Then we define a const variable, a const object. We call this show. Which one is called? So if this is const object, it will call this const version of the function, member function. Okay, and because the object is const, we cannot call this non-const function, member function. This causes error. Okay, so this is const and non-const, and we can convert between const and non-const. So there are two functions. One is const cast. This is used to cast away the const. As const is to cast from non-const into const. So there are two ways. Actually, this is not suggested usage in most cases, but there's one acceptable usage. It is called in our book const and back again. Right? So the key idea is that we have a const version of a function. We may return something here, and then if we want to define a non-const version, and maybe its function body is similar, then we can just use a const version. First, convert the object into a const version, then we call the const version, right? And then for the return type, we do by cast it into non-const. Then this is kind of we can call the const version in the non-const. Then we come back again. Actually, we return it into non-const. Right. So this is a typical usage. this is within our book, actually. You can read it later. And the following usage are dangerous and unsafe. So I suggest you not to use it unless it's really have to. Otherwise, you don't need to. You should not do that, because for a const object, because it is already a const object, it is not suggested to be modified. But you still want to modify it, maybe errors will be caused. Okay. Then there's top level and low level const. So we can define const in two ways. One is here. This is called top level. This is const pointer to a mutable object. That means this pointer is const, the value of the pointer is const, but the object is mutable. We can modify the object. And low level const is a const object that a mutable pointer points to. So that means this pointer is mutable. It can point to any different objects, be modified. However, the object is const. So this is low level const. So const is here. Okay. So these are, be careful about this top level and the low level const. Actually, the second one, this one is typically used, right? In most cases. Okay. Now we have a 5 minutes break. If you have some questions, you can we can discuss now. So you can send some blitzscreen message. 就是现在休息5分钟，大家有问题可以现在发送一些弹幕过来啊。刚才可能有个别问题没有很好的答复，因为刚才在上课的时候，时间关系来不及那个很好的那个答复。Non-const object, I think you can use as const. If you use as const, we just learn this as const. So if you want to call the const version of show, you can use as const, right? As const, and then you can call the const version, right? First, you convert your object into const, then you call the const version of the member function. Okay. Top level. 就是说这个就 top level 的top level 呢是指针指向的对象是可以改的，就是说我 PA 指向的 modify 指向 modify 本身就是可以改这个对象内容的一个成员函数嘛，就是改成员变量值的一个成员函数，所以它是可以改这个对象的，所以这个是这种 top level 是这样的，它是指针是不能改了，指针不能变了，指针只能指向这个对象了，但是可以改这个指向的对象的内容。但 low level 呢，它是对象不能变了，对象不能变，但是我指针可以指向不同的对象，就这个对象我一开始指向了 B， 那现在我就指向 C， 这没有问题。但是这个对象，因为对象本身就是 const， 所以呢，指针指向的对象我不能再调，比如说 PB 指向的 modify， 这是不行的，这是不行的，因为这个对象是 const 类型的，所以我不能再调用 PB 指向 modify， 这就错了。How to contribute to QA list? You mean the GitHub QA list? For the GitHub QA list, we will make some assignments later in our homeworks. We will tell you how to contribute to our QA list in GitHub. Actually, I think you have a lot to contribute. Because QA list is only very limited content, I think. For example, for our CPP 17, there are many new grammars that is not covered in our QA list. So, and also actually in our QA list, the writing is not good, and there may be even some English grammar errors. You can also, I think, you can also contribute in that way. That's also fine. But if you can contribute in some new grammars and new programming skills, that's much better. I also think for our in-class presentation, there are something to contribute to our QA list because someone may talk about, for example, CMake, may talk about the Valgrind, GDB, and gprof, different topics. I think you can also contribute to QA list. That will make our QA list more more how to say that more powerful, or there's no more knowledge, right? More knowledge points or more topics, so that in the future our students can learn more from the QA list. 就我们这个 QA 的这个 GitHub， 我们后面会在大作业中会讲这个事情，要求大家怎么样去改进。C++ 17里边这个对这个什么的这个大括号啊，就是在初始化的时候啊，就是我们看都是在初始化的时候开始用这个。Okay, let's start our class now. 课程回放，我们到那个网络学堂去下载这个视频自己来看。网络学堂那个公告里面有这个视频下载的地址，就是在清华云上面我们放了这个视频录制的视频。Okay, let's continue our class. So for this function like macros, the function like macros actually is error prone. For example, for the first one, actually there's some error. For example, if we use the function like macro in this way, we will get 2 characters, right? Because this is this one, C here. So we have the we will get C here, right? C. So we get char here, and also get char here. So originally we only want to get 1 character from the command line input and check the character whether it is between A and Z. But now, if we use the macro in this way, we are getting 2 characters. We are calling this function twice, right? So this is an error, okay? So efficiency, for example, if we use max in this way, then we are computing this x twice, right? Because this is this one will be put here, and this one will be put here. Again, we are computing this value for 2 times and computing this value also for 2 times, right? So this efficiency problem, and also there are some error-prone problem. So for this area, if we define area R like this, then if we call this macro in this way, so we will get this one. However, because there's no parentheses here, and there's the value is error, right? The value is wrong. So if we use macros, it is very important that we should have a parenthesis at the outermost. We have the parenthesis. Okay. In this way, we can avoid some errors. Okay. So macros are really error prone. So we suggest you to use inline functions. We will learn inline functions later. Okay. So now we will learn function overloading. We learned from last class, we know that we have different versions of the constructors. So sometimes we need more than one versions of constructors. For example, for bookstore, we may have one way of constructing this default object. Another way to construct a more complicated object. So there are different versions of the functions. How to how to allow this kind of overloaded functions. So this is a new demand in the new language, CPP. Originally, it is not allowed or supported in C language, okay? So it is introduced in CPP language. And it is basically used to allow multiple constructors in one class, but it can also be used for general functions. Okay, so if you are a designer of GPP, how to modify the old compiler to support this function overloading? The idea is to reuse original compiler, and transform functions into the general functions like this. For example, here, if we define a function like this and a function like this, then we can translate or transform the two functions into two different functions with different names. In this way, we avoid this duplicates of function name, and the original compiler can compile it. We will learn Mu constructor later. Okay, so Mu constructor is related to copy constructor. We will learn this later. Then for this scope, if we use XF, we can define it as this. That means if we define class member function, so we can translate class member function this way. Okay? Why not return type? We are overloading by parameters, actually. We cannot overload by return type. That is because if we have two versions of overloaded functions, one return void, one return integer, then if we have this function call, we don't know which version is called, right? Reader cannot know, compiler cannot know. So that's why we do not use return type for overloading functions. And then here are some grammars. So this one, I think this is easy, and these are similar, and this one is array and this pointer. They are regarded as identical signature, so they are regarded as the same, and these two are regarded the same. So I think this is easy. Sorry, this should be this should be P2, right? Okay. And and this one is another grammar. So this is non-reference parameter, and this is reference parameter. So we will learn reference later. Actually, we can for now we just need to know that reference is a constant pointer. Constant pointer. That's fine. Okay. Then if we define these two overloaded functions, if we define these two integers like this, and then we call double version, because compiler will not use a temporary address to initialize the reference to non-const. So this one, if we call it in this way, we are converting from integers to long variables, and this static cast actually generates a temporary. So this temporary is a temporary object. So this temporary object, for this temporary object, we cannot have a reference. We cannot have a reference. So we cannot call this one. So in this case, we can only call this double version. This double version. But this function calls this double version. Okay. So if we really want to, in this case, if we really want to call this long version, then we have to modify it in this way. So a constant reference takes temporary values. So that's grammar. That's the grammar. So constant reference parameters takes temporary values. Okay. This grammar. Actually, this is from our book. I think if you read the book, you'll get a better idea about this. And also for const parameter is only distinguishable from non-const parameter for references. The const reference pointers. If we define const int and const, they are not differentiable. Right? So for fundamental type, const int and the int are the same. So const pointer and the pointer are different. Okay. So these are this is similar because this in this way, if we use this parameter, that means we cannot modify this this pointer. Right? Then for this one, this pointer for this one, we can also actually this pointer is passed by a value. For example, if we have a integer a, and then we call this value, oh, sorry. This is, sorry about that. And a, like this. Actually, this pointer value is passed by value copied to this a. So there's no need to modify this value of a, but we want to modify the object pointed to by a, right? So sorry, I think something wrong here. Oh. Okay. So actually, we are passing value here. So by this const, there's nothing. This means nothing because modify this value is meaningless. 就是我们改这个，因为它是 const 的 pointer 本身是 const，但我们其实不需要改这个 pointer 本身，我们只是需要改 pointer 指向的那个对象或者指向的那个变量。所以这个时候啊，我们这样的 const 是没有什么意义的。所以这两者是一致的，或者是就认为是一个版本就可以了。Okay. And this one and this one are similar because this is also this const, right? The only difference is this const. This means we do not want to modify this pointer. Actually, modifying this pointer is meaningless, so we don't want to do that. So they're identical actually. Okay. Now we learn default arguments. Default arguments. Actually, default arguments is function arguments in declaration with default values. And the compiler will automatically assign the values to the parameter. For example, for this one, we have two overloaded functions like this. In this function, we have another parameter b, actually is assigned to 0. Maybe it is b0, right? In this function body, right? And then we have another simulation function here. Then we can combine these two functions into one version. That means because the function body of the two versions are similar, the only difference is that in this one we can give b a value, right? B a value, maybe a different value, maybe b, for example, maybe this value is 10, for example. But in this version, the value is 0, right? Then we can have a default value, and combine these two. The users can either use this one. If the user calls the function in this way, then the default value is used. Then this function body actually is used, right? If the user calls the function in another way, this way, for example, then this one is used, right? Then we can combine these two function body with very similar function body. Only difference is the value of b. Then we can call this in this way. Then we can combine the two functions into one. Okay. So this is grammar. Grammar is that we can only default to the tailing arguments. Okay. This is the function declaration, and this is function definition. And we give the default value in the function declaration, and we cannot do that in this in the function definition. We cannot give the default value here. Okay. So this is I think there's something related to this in Google coding style. Okay. Now you can read it and learn more about that. Here's an example of why the only tailing arguments can be defaulted. This is because if we call the function in this way, this is the defaulted tailing arguments. But if we do not have that rule, we can default anyone. Then we have different explanations of calling this function. There's ambiguity or errors sometimes. So we cannot know which one is called, which version is called. So by this tailing argument rule, we have a single determination. We have a single, we know that only the last one is defaulted. Okay. So for function overloading and the default arguments, there are some, I think they are very similar, but there are some difference. First one is overloaded functions have multiple function bodies, and default arguments have only one function body. So for overloaded functions, the code will be larger, right? The compiled code will be larger. And the design principle is that we should always consider easy for use and reuse. Easy for use and reuse. For example, for default arguments, so function arguments have default values. Whenever we have some suggested values, then we can use default arguments. Okay. And it's useful if we only want to add the new parameters for existing functions without affecting the user programs. And for overloaded functions, we add the new parameters. If we want to add new parameters, we have to add a new function. So we should try to avoid code duplicates. If we just add a new parameter, then we add a new function, we'll have to duplicate the function body, right? So that is kind of, we should try to avoid that cases. Here's an example. For example, if we have a function definition, or function like this, function definition, I have one parameter inside, and then we have some user programs, FA, and there are other some, sorry, sorry about that. So we have some function definition, and we have some function call with the user program. Then maybe in the future, we know that, okay, actually in this function body, we have the b.0, b value of b is 0. Maybe in the future, we know that, okay, we want the user to choose the value of b. Then we have to add another parameter, right? But we can have a default value like this. Oh, sorry. This sorry about that. So this int a is so we have this value here. Originally this is b0, and now we have this. So we do not need to worry about the user program. They are still useful, right? Still useful, and because default value is like this, right? So then for new users, you can use, you can have this, right? So this is in this way, we add a new parameter into the function. We modify this function, and we do not use this anymore. But original users are not affected, right? And this way, we can avoid duplicates of the function body. We only have one function body, okay? Okay, then that's all for today's class. We learned function overloading and default arguments. And this week, we want you to do some code review, to review others' code to learn. Now,